This is lesson 2.6, Algebraic Proof. Your objectives are to use algebra to write two-column proofs and to use properties of equality to write geometric proofs. A list of algebraic steps to solve problems where each step is justified is called an algebraic proof. The table shows properties you have studied in algebra. So take a minute to look at the table. In algebra, when you add the same thing to both sides, that's the addition property. If you subtract the same thing from each side, it's subtraction. If you multiply both sides by the same thing, it's multiplication. And if you divide both sides by the same thing, then it's division. For the reflexive property, A equals A. Any number equals itself, like 2 equals 2. For the symmetric property, if A equals B, then B equals A. If X equals 3, then 3 equals X. You can switch things around the equal sign. And for transitive, if A equals B and B equals C, then A equals C. So if the first thing equals the second and the second thing equals the third, then the first equals the third. For substitution, if you know the value of a variable, you can substitute that value in for the variable in any equation or expression. And then the distributive property, if you have something times a quantity, do the outside times each item inside, A times the B and A times the C. These properties will be the reasons to justify each step in our algebraic proof. So make sure that you refer to it, you keep it handy, and you decide which property is happening each step of the way. Complete each proof. Given 4x plus 6 all divided by 2 equals 9, prove x equals 3. With this, make a two-column proof, a column of statements and a column of reasons. The one they have here is fill in the blank. So we will fill in the blank until we work our way all the way down. To start, we know that 4x plus 6 over 2 equals 9, and the reason is given. The first statement is always the given statement, and the first reason is always the word given. Now work this out just the same way you would solve an equation. Since they multiplied the right side by 2, and the reason is multiplication, you can guess that they will also multiply the left side by 2. And we do that so we can cancel out the fraction. On step C, they simplified everything and made it a simpler expression on each side. And when that happens, it's substitution. On step D, they subtract 6 from each side. That will be subtraction. Remember to not abbreviate substitution or subtraction with the word sub. So write both of those words out so you don't confuse them. On the next line, the reason is substitution, and that's when they simplify each side. The left side became 4x, and on the right, 18 minus 6 is 12. On the next line, they say the division property, and if we were solving this equation, we would obviously divide both sides by 4. They've done the left side, now do the right side. The last reason is substitution, and if you simplify both sides there, you get x equals 3. My proof is now done because I have said what I was asked to prove. They said, prove that x equals 3, and I said it. And that's when you're done. So when you do a two-column proof, remember, your first statement will be what you're given. The first reason will always be the word given. We know that's true because it was given to us. Whatever you're trying to prove, that's the last statement. So any proof will flow just like that. the given on top, and the statement you're trying to prove is the last statement. Question 2. Given 4x plus 8 equals x plus 2, prove that x equals negative 2. So I'll solve this just like I solve an equation. That would be under the statements column, and the reasons that justify each step will go in the reasons column. As always, you start with what you're given, so statement A is the given information. Reason A is the word given. I know that's true because it was given to us. On step B, they subtract x from each side, so that will be the subtraction property. On step C, they simplified things, so that's substitution. Reason D, they say the subtraction property. What would you be subtracting from C to D? Well, you would subtract 8 from each side. Then they simplify things there with the reason substitution. The 8's cancel on the left, and 2 minus 8 is negative 6. On statement F, they divide both sides by 3. That's the division property. And finally, they say substitution, and that's when they simplify both sides. X equals negative 2. Notice that was the statement we were trying to prove. We finish when we can say that. What we're given is the first statement, and the first reason is the word given, and the last statement is what we're trying to prove. Geometric proof. Geometry deals with numbers as measures, so geometric proofs use properties of numbers. Here are some of the algebraic properties used in proof. The reflexive property, where a value equals itself. For segments, a segment measure equals a segment measure, and for angles, an angle measure equals an angle measure. For the symmetric property, if one thing equals a second thing, then the second thing equals the first thing. Notice how it switches around the equal sign. For transitive, if the first thing equals the second and the second equals the third, then the first equals the third. All three of these properties can deal with segment measures or angle measures. Write a two-column proof to verify this conjecture. Given, measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, prove that the measure of angle 1 equals the measure of angle 3. Well, notice how the very first statements that they say are the given statements. And the reason is the word given. Now, how can I prove that the measure of angle 1 equals the measure of angle 3? Well, if the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, then the first one has to equal the third one. That's the transitive property. Just like we see here. If the first is equal to the second, and the second is equal to the third, then the first equals the third. And to finish it up, we were asked to prove measure of angle 1 equals measure of angle 3, and we have proven that. So the proof is finished.